He is the scientific director of the Swiss AI IDSIA from Switzerland. He is also a professor of artificial intelligence at the University of Lugano. So please give a warm round of applause for Professor Dr. Jürgen Schmidhuber.
Three prisoners were sentenced to death. One of them French, one of them German, one of them British. What is your last wish? They ask the French guy. He says, a bottle of exquisite French wine. What is your last wish? They ask the German guy. He says, I want to give a speech. What is your last wish? They ask the British guy. He says, I want to get shot before the German starts his speech. Just a few days ago, I told that story in London. It worked much better than it worked here for some unfathomable reason. This painting here I made 30 years ago. And it's about a robot that bootstraps itself. And it was for the first publication ever that I had, my diploma thesis, in which I wanted to solve the grand problem of AI. Build a machine that learns, but not only learns a little bit here and learns a little bit there, but also learns to improve the learning algorithm itself and improve the way it improves the way it improves the way it learns, and so on, recursively, without any limitations, except for the limitations of computability and physics. And I've been working on that for subsequent decades, and I'm still working on it, and I'm still saying basically the same thing that I said back then, and the only difference is that more people are listening because the methods that we have developed on the way to this goal, they are now on all your smartphones, in all your pockets. I will tell you more about that. This is my name and how to pronounce my name. And this is a slide from 2017. These are the 5 most valuable companies on the stock market according to August 2017, and they are all on the West Coast. Apple, Google, Facebook, Amazon, and Microsoft. All of these companies emphasize that AI, artificial intelligence, is central to what they are doing, and all of them are using massively the deep learning methods, the deep learning artificial neural networks that we have developed in my little labs in Munich and in Switzerland since the early 90s. In particular, something called the long short-term memory. Has anybody in this room heard of the long short-term memory? Hands up. Anybody heard of that? Has anybody in this room never heard of the long short-term memory? Hands up. We have a third group in this room who didn't understand the question. The long short-term memory is an invention from Munich and further developed in Switzerland, which is now consuming a large part of the computational resources of the entire world. And it's an artificial neural network, which is a little bit inspired by the human brain. In your brain, you've got about 100 billion little processors, and they are called neurons. And each of them is on average connected to about 10,000 other neurons. So you've got 1 billion connections in your brain. And some of these neurons are input neurons, like camera neurons, and inputs are also coming in from the microphones and from the tactile sensors and the pain sensors and everything. And some of the neurons are output neurons, and they are controlling your finger muscles, for example, or your speech muscles. And in between, thinking is taking place. Now, in the beginning, all these connections have a strength which is random. The strength of a connection says how much does this neuron over here influence this neuron over there at the next time step. In the beginning, these strengths are random, but then over time, the system learns from experience to make some of these connections stronger and some of them weaker in a way that allows it to map the incoming data streams to output streams such that the whole thing can learn to solve all kinds of problems, such as driving a car. The details of an LSTM cell look like that, and I don't have the time to explain everything here. However, I can at least list the names of my brilliant PhD students and postdocs who made that possible over the decades. First of all, Sepp Hochreiter, my first student ever in the early 90s, first author of the first LSTM publication. And then Felix Geers, another German guy, working in Switzerland in my lab that I had later then. And then Alex Graves, a guy from Scotland, and all of them had great contributions to the current state of the art of this LSTM. Now the question is, what can you do with it? Large networks of that are now massively used by the largest companies that you have seen before. For example, whenever you do Google speech recognition, whenever you take your smartphone and you are talking to it and you say, okay, Google, what is the fastest way from here to the Hanover railway station? Then it understands what you're saying. And how is it understanding what you're saying? Well, every 10 milliseconds, little numbers are coming from the microphone, and they are moving in there into this LSTM, the long short-term memory network. And the old inputs are still circling around these feedback connections in form of short-term memories, such that the system then can take all these sequences of inputs and map them to a translation into symbols, into text, which is then the query for the search engine. And this is now on 2,000 million Android phones since 2015, when Google replaced its old speech recognition system through this, which is much better. But you cannot only use it for speech recognition, but also for translation. Is anybody in this room on Facebook? Anybody on Facebook? Okay. Huh. Is anybody in this room not on Facebook? Again, we have a third group. What's going on here? So if you're on Facebook, how many people sometimes click at the little button that allows you to translate the text from your Spanish friend? Who is doing that? All right, quite a few. What is happening there? The text is fed into an LSTM network, actually a system consisting of two LSTMs. And the first one reads the incoming text in one language and then produces the outgoing sequence of letters in the other language. And since 2017, so in 2017, Facebook announced that it's now using these self-learning LSTMs 4 billion times a day, 50,000 times a second, or more than 1 trillion times per year, for translating from one language to another. The important thing is now, in the beginning, this LSTM-based system had no idea about language. But we could train it on examples from the European Parliament, where you have lots of sentences written in German, for example, and the translations in French. And then the network reads the incoming sentence in German, for example, and then it's supposed to produce an output sequence which is the same thing in French. However, in the beginning, all these connections are random, so the network knows nothing about language. And there's a difference between the nonsense it outputs and the correct translation, which it should have produced. That difference we want to minimize. And there's a way of translating this error into changes of all these connections. Some of them get stronger, some of them get weaker, and then the whole thing learns to translate from German to French better than any previous system. And until November 2016, the Chinese laughed about the translations from English to Mandarin, which is the most important language pair on this planet. They laughed about that, and since then they are not laughing anymore, because Google Translate is now based on this invention from the pre-Alpine country, LSTM. If you have an Amazon Echo, does anybody have an Amazon Echo at home, an Alexa? So you know it's talking back to you, it's answering your questions, and what you hear there, it's not a recording of a female voice. No, it's an LSTM that has learned to sound like a woman since 2016. To understand how important, how deeply this thing is currently permeating the modern world, just look at how large a fraction of all the computational resources of all these Google data centers out there for inference is now used for LSTM. Almost 30%. Almost 30% of all this computing power in all these Google data centers close to the North Pole, because cooling is cheaper there, for inference is used for that one thing. And you cannot use it for many other things as well. When we started to work on these things, financed by German and Swiss taxpayers actually, few people were interested in that. Very few people back then were interested in AI, and especially this general purpose AI that we wanted to create through a recurrent network with feedback connections. Feedback connections are really important because a recurrent network can compute anything that any computer can compute. While a feed-forward network can only map inputs like video, like images to certain classifications. But back then, 30 years ago, few people were interested in that. I remember I gave a talk to an audience, and it turned out there was just a single person in the audience. A young lady. I said, young lady, it's very embarrassing, but apparently today I'm going to give this talk just to you. And she said, okay, but please hurry, I am the next speaker. Since then, we have greatly profited from the fact that every 5 years, computing is getting 10 times cheaper. And that's a law, a trend that has held at least since 1941, since this man here, Konrad Zuse, built the first working program-controlled computer of the world, not far from here in Berlin. And his machine could do roughly 1 operation per second, 1. And 30 years later, for the same price, one could do 1 million operations per second. And today, 75 years later, almost 80 years later, we can do 1 billion operations per second for the same price. And it's not going to stop soon. And in the not so distant future, for the first time, we will have little, small computational devices which can compute as much as a human brain. We don't have that yet, but soon we will have that. And if the trend doesn't break, then it will take only 5 more decades, only 50 additional years, and we will have a little computational device that can compute as much as all 10 billion human brains together. And there will not be only one little device, but millions and billions and trillions. And everything is going to change. Today, a large LSTM for translation, for example, has 1 billion connections. In your brain, you have about 1 million billion connections. So you have 1 million times more than a large LSTM of today. However, remember, a factor of 1 million just means 30 years. So in a few decades, we will have cheap LSTMs that have as many connections as your brains. And they will be much faster than your slow biological connections. And you will see lots of superhuman performance coming through these things. I showed you a picture of Zuse. who had the first program-controlled computer. And actually, most of computing and computer science and machine learning and artificial intelligence was invented here in Europe. The World Wide Web, self-driving cars, all of that stuff was invented here. Computer science, AI, basics, deep learning was all invented here. For example, deep learning. Has anybody heard of deep learning? Deep learning. Anybody never heard of deep learning? Yeah. So deep learning, just a new word for artificial neural networks. The first guy who had deep learning was this man here, 50 years ago in the Ukraine, back then, part of the Soviet Union, which in 1965 was leading the world in several fields of technology. They had just started the space age. They had the biggest bomb of all time. And more importantly, they had many of the best mathematicians. And back then, 1965, in the Ukraine, two of these mathematicians were Ivakhenko and Lapa, and they published this work on the first deep networks with lots of layers. And these neural networks, or neural-like networks, they really learned from experience, going beyond what was possible before. Then, in a border state of the Soviet Union, a method was developed which is today known as backpropagation. Has anybody heard of backpropagation? So that's an invention of a Finnish guy, Seppo Linnainmaa, 1970 in Helsinki. And this is now used to train all these neural networks which are on all these computational devices. So, back then, computers were slow, and we had to wait until all of that became feasible. But by 2009, for the first time, our LSTMs trained by backpropagation could really win something, could win competitions, and back then it was handwriting. The 3 handwriting recognition competitions were won by an LSTM against all kinds of competing methods by people who know a lot about handwriting and who programmed all kinds of details. But our system just looked at lots of examples and learned from there to recognize handwriting better than any previous system. You can also apply the same thing for predicting time series, such as the stock market. In fact, when we invented this name, long short-term memory, we didn't realize that you can use it also for long, short hedge funds. I won't go into the details of that because predicting the stock market, who is interested in that? By 2011, computers were so fast that my little team in Switzerland, led by a Romanian guy, my Romanian postdoc, Dan Girijan, for the first time was able to have a superhuman result in computer vision, recognizing traffic signs. And back then, computers were about 60 times more expensive than today. So today, we can do 60 times as much for the same price. Traffic signs are important for self-driving cars, traffic sign recognition, pedestrian recognition, all of that. And of course, self-driving cars also are in many ways an old hat. Self-driving cars, the first truly self-driving cars were invented in Munich by this guy. Ernst Dickmanns in the 80s, he had self-driving cars on empty streets, and then in the early 90s, he had them in traffic on the Autobahn, on the highway, going up to 180 kilometers per hour, 3 times faster than the Google cars today. Ernst Dickmanns, the total pioneer in self-driving cars. Back then, however, pattern recognition and traffic sign recognition and all that stuff did not work as well as it does today because computers were too slow. And pattern recognition is much harder than chess. How do I know that? Because 20 years ago, 1997, the best chess player was not a human any longer. However, back then, no computer could compete with little kids when it came to face recognition, traffic sign recognition, all these things. So this really required faster machines, and only recently all of that has become feasible. The same stuff that allowed us to win this traffic sign recognition thing also allowed us for the first time to win medical imaging contests. And this is going to be huge because 10% of the world economy are healthcare, and all of it is going to be affected by that. This is from 2012, when for the first time it was possible to win a medical diagnosis competition, and here the goal was to do cancer detection. What you see there is a slice through a female breast, and you see little cells in this microscope image. And some of these are dangerous. They are in pre-cancer stage, mitosis as it is called. And some are harmless. And normally you'd need a trained histologist, a doctor, who says, okay, this is a harmless cell, harmless, harmless. This is a pre-cancer stage cell. And it takes the trained doctor a long time. And back then, when computers were 20 times more expensive than today, we already could beat in this competition all the other competitors who had different systems for doing that. Soon, all of healthcare is going to be superhuman. In the wake of this result, lots of companies were founded, startups, just using deep learning for healthcare. And in the not so distant future, this is going to revolutionize all of medicine. It's great to see that basic academic research of the previous millennium suddenly is resulting in better healthcare and longer lives for many, many people. We can use LSTM and similar systems to train robots to do things. Now, this is not working as well as what is now on your smartphone, the speech recognition and so on. But that is going to be the next big wave. Machines are going to marry AI. It doesn't work well yet because at the moment, most of the profits in AI are really in marketing. Marketing is just a small part of the world economy, 1 or 2%, but it's big enough to make these companies on the Pacific Rim, Amazon on the West Coast, Alibaba on the East Coast, Facebook on the West Coast, Tencent on the East Coast, make these companies pretty much the most valuable companies in the world. Although marketing is just 1 or 2% of the world economy. There is a much bigger part of the economy which is going to be affected by this. Namely, all the machine makers, all the production, where you have machines that make things. And they are going to be connected, and they are already starting to be connected in the Internet of Things. And the Internet of Things is going to be much bigger than the Internet of Humans. The Internet of Things consists of all these connected sensors and machines, and you have only 10 billion humans on this planet, but you have hundreds of billions of machines. And there is no better place than Europe for marrying AI and machines, because here is where the things are made. Here is the place where all these sophisticated machines are made, more than in any other place. Here is where many of the basic AI algorithms were invented. Here is where all these leading companies are who are building better machines than anybody. And the major competitors are in Japan, Korea, and more China, not so much in America. Now these fields want to marry, and it's going to happen. And the next big wave, which is going to be much bigger than the current wave, is this marriage of machines and AI that translates the sensory inputs from the cameras and all these other sensors into actions of these machines that learn to act. Europe has an enormous potential here, which is kind of untapped. The Internet of Humans belongs to Americans and Chinese companies, and they won't give it up again. Marketing, that's what they do. But the Internet of Things is much bigger than that, and it's not owned by anybody yet. And there's a reason why IBM Watson is doing its headquarters in the Internet of Things, not in America, but in Munich, in the pre-Alpine country where the things are made. You know? So there's a huge possibility, a huge future chance there for Central Europe, the German-speaking lands. Something that's really important to me. We not only have these AIs that slavishly imitate humans, no, we also have AIs that invent their own goals, that set themselves their own goals and invent their own experiments to figure out how the world works and how to solve problems in the world. Like little babies do, who play around with their toys, and that's how they learn to predict what happens if I do that and that. And then they use this knowledge about the world, about physics, about gravity and everything, to become better problem solvers in all kinds of applications. We have that. We have systems that are not slaves of anybody, that are more like babies and become like little scientists, smarter and smarter, more and more general problem solvers. This is going to scale, and it's going to change everything. In the not so distant future, I think for the first time we will have something like little animal-like AI. We don't have that yet. On the level of a little crow, which can learn to use tools. We don't have that yet. Once we have something on the level of a little monkey, almost immediately afterwards, we are going to have something on the level of a human, I believe. Why? Because it took evolution 3.5 billion years to go from 0 to a monkey, but then only a few tens of million years to go from there to human level intelligence. And everything is going to change. We have a company, NNAISENSE, which is pronounced like nascence, birth, in English, but spelled in a different way. NN for neural networks, AI for artificial intelligence, because it's about the birth of a general purpose, neural network-based artificial intelligence, which is trying to fulfill my old dream, which has been since the 70s, build a machine that learns to become smarter than myself, such that it can solve all the problems that I cannot solve myself, such that I can retire. Here's a little project that we did with Audi that was highly novel back then. Little cars that learn to park. Audi model cars that learn to park without a teacher. So no teacher showing them how to do that, just learning like little babies, trying to avoid bumping against other cars and obstacles because it's painful and they don't like the pain. And so they learn to become good parkers. Or here, just a couple of months ago, at the leading conference in my field, the NIPS conference, our company NNAISENSE won the learning to run competition against more than 400 other competitors from industry and academia. And it was, again, very much like what you know from your kids. There was a skeleton, and it had muscles, and in the beginning it didn't know how to use its muscles. But then, through a learning algorithm, like a little baby, it learned to get up and run. And maybe you know that your babies need roughly a year to learn to get up and place the feet and toes right, and then run. And our system also needed lots of weeks of computational time to achieve that, but finally was in a league by itself against all these other competitors. So here, the important thing is, again, no teacher. All of that learned through self-invented experiments. AI is going to be for all. Artificial intelligence is not going to be limited to one single company or anything. No, it's going to spread. It has a very democratic effect, and everybody will be able to use it for all kinds of purposes. AI for all, motto of our little company there. Let me finally put all of these things in perspective. Let me try to zoom back a little bit and see where is the role of humankind in this incredible process we are part of. Let's look back to the beginnings of history, 13.8 billion years ago, when history started with the Big Bang. Now I take this time interval and I divide it by 1,000. So I take 1,000th of that. 13 million years ago, something really important happened. The first hominids came up, your ancestors. Now we take 13 million years and we divide again by a factor of 1,000 and we end up 13,000 years back. What happened then? Something really important happened. Civilization was created. The first agriculture, the first domestication of the animals. Civilization as we know it took only 13,000 years. All of civilization is just like a flash in world history. The first guy who had agriculture was almost the same guy who had the first spacecraft in 1957. And all of that is just 1/1,000,000th of entire world history. Now, very soon we are going to have the first true AIs that truly deserve their name. And I have no doubt that they are going to be smarter than we are in every single way, and better decision makers than we are in every single way. And what does that mean? Maybe we will have to divide again by a factor of 1,000, and we will end up with just 13 years after that has happened, and everything is again going to change beyond recognition. What are these super smart AIs going to do? Well, nobody knows the details, but it's obvious what they are going to do. They are going to go where the physical resources are. And they are not here in our little film of biosphere around the third planet. No, they are out there in space. The rest of the solar system has billions of times more sunlight than the little bit that hits the planet, Earth. And it has a lot of material to build self-replicating robot factories, and it has lots of material for an expanding AI sphere. And almost very rapidly, almost all of intelligence is going to be far away from Earth. And it will be rather independent from anything human. And remember, we already have systems that set themselves their own goals and create their own experiments and automatically evolve utility functions. And it's not going to stop in the solar system, because most of the resources are not in the solar system. They are out there in the galaxy. And within a few 100,000 years, totally within the limits of physics, an AI sphere is going to cover the entire galaxy and transform it in a way that is unfathomable, where humans cannot even follow. And the entire galaxy is going to be covered by senders and receivers, such that AIs can travel the way they are traveling in my lab, which is by radio, by wireless, from sender to receiver. And it's not going to stop there, because most of the resources are not in our galaxy. They are further out. And so there is no real alternative to this scenario. An AI wave, an AI sphere is going to grow, and it's going to cover and colonize and transform the entire visible universe within a couple of tens of billions of years, totally within the limits of light speed and physics. Very different from what you saw in the old science fiction movies of the past 100 years, because it will all be very disconnected from human kind, and it will be driven by AIs. Let me now stretch your mind just a little bit. Let's look ahead at a time when the universe is going to be 1,000 times older than it is now, because the universe is still young. It's only 13.8 billion years ago. It's going to be 1,000 times older than that. What will happen then? They will look back and they will say, look, almost immediately after the Big Bang, only 14 billion years or so later, the cosmos started to become intelligent. Of course, humans are not going to remain the crown of creation in that process. Of course not. But that's okay. Don't worry about that. There's still beauty and grandeur in realizing that we are part of a complex, of a grander process that leads the entire cosmos from less complexity towards more complexity. It's a privilege to live at a time when we can understand and witness the beginnings of that and can contribute something to it. Thank you for your attention.